once we have gathered all this information, we proceed to analyzing the text in the following way. We find all the occurrences of known aliases in the text. This generates a large number of potential links to various entities in our database. For example, for a typical news article, that generates around 2,000 potential links. You can see that this long list of potential link candidates contains all sorts of entities that have no relation to the text we're analyzing. Like for the word small, we get a list of all people that have surname Small, which of course in this context is completely irrelevant. You can also notice that potential links can also overlap. So in addition to disambiguating the meaning of each word, we also have to resolve such link conflicts. Now how do we do that? We calculate a number of features for each candidate links. These features are numerical values, and they range from traditional similarity measure like TF-IDF. This is a number that represents similarity between the text we're analyzing and the text on the destination page. We also compare the named entity status. For example, does the text show that this is a named entity, and compare it from what we know about whether the destination page also talks about a named entity. Named entities, by the way, are things like personal names, company names, brand names, and so on. We also compare parts of speeches. Parts of speech, whether a word is a verb, whether a word has been used as a verb in Wikipedia, and whether it is used, for example, as a verb in the text we're analyzing. And you also have a bunch of other features that are much more trivial, like whether the capitalization is correct, and so on. Now, the result of this disambiguation looks like this. And now, of course, although I have seen Wikipedia articles that look like that, this is really not useful for human consumption, right? Nobody needs explanation for common words like word, month, string, and so on. However, we can use this output to enhance computer. Okay, thank you. To enhance computer processing of text. Maybe I forgot to mention that one of the reasons why we would want to do such automatic link generation is also that traditional text retrieval methods, information retrieval methods like search and, for example, finding related articles cannot usually disambiguate the term of the meaning of words. They work based on words. So for an article like this example, for example, which is talking about technology, they could, for example, suggest an article about the animal, the puma, because puma animal, because it's the word in there. So if we fit such an information retrieval system, the output of this algorithm, where each word has been linked to an identifier that links to, that represent a single entity, then the precision of such information retrieval systems can be dramatically increased. Now, however, if you want to present such links to a human reader, we must perform another step, and this is we have to select those links that a human reader may find convenient. Now, we do this in a similar way. We calculate a number of, again, numerical features for each candidate link, and these features are this time designed to present the desirability of links for an average human reader. These features include like the possibility that the anchor is a proper noun, because proper nouns are usually more desired links than other kinds of words. An important feature is also to check how many times this alias appears as a link anchor in Wikipedia and how many times it appears only as plain text. So we try to extract the common sense of Wikipedia authors from this. We also compare other parts of speeches. Now, it's important that we also do this link selection automatically, because one of the reasons why we would like automatic link generation is also that the author may not be the best one to decide which links may be convenient to the majority of his readers, right? The author knows, or at least should know, what he's writing about. So he may not be the best to judge which links are best for his readers. So such an automated system that learns on a large amount of text that is available in Wikipedia may be better at judging that. So after this final selection, we end up with a text that has properly marked up only the word that that a human reader may need explanation for. However, we can do more. Since we have linked each word to a Wikipedia URL, and Wikipedia also provides some deal of structured information that can be extracted from